Hi class, today I want to talk about particle accelerators. The reason for this is because we're going to, in the next couple of classes, be talking about subatomic particles and how do we figure out all the different kinds of subatomic particles we have. Well, one way to do that is to smash things together and see what comes out. But in order to smash things together, you have to get them up to fairly high speeds. So today I want to talk about particle accelerators, and then that will lead into further discussions of the atom. Okay? So a particle accelerator is just something that speeds up a particle, accelerates it. You remember acceleration is the change in speed over time. And the way we can accelerate particles, if you look at this picture here, if we make one plate, let's say negatively charged here, if we had a buildup of electrons on here, and we made the other plate positively charged, well, we know that opposite charges attract. There's a force, an attractive force between oppositely charged items. So for example, positively charged particles will attract negatively charged particles and vice versa. Negatively charged particles attract positively charged particles. So if we put negatively charged electrons over here and we put a positively charged plate over here, what's going to happen is some of the electrons will jump off because of that force, that attractive force that will jump off. And if we put just a little hole here in the middle of this positively charged plate, these electrons, some of these electrons will go through the plate and travel over and hit a screen over here. This is a cathode. This is basically how old television sets used to work. Let me show you a quick animation of that. Okay, so here we have our plates, and let's just play that. And so you can see little particles coming off, accelerating from this plate to this plate, and then traveling through and hitting the screen over here. But the important part that I want to highlight is that there's a force on these particles, right? When we have a negatively charged plate and a positively charged plate, there's a force on these particles, and that force causes the particles to accelerate. Remember, F equals ma. So let's go back here. F equals ma. That's our old friend F equals ma. So it describes the relationship between when you put a force on a particle, it's going to accelerate, and it's going to be proportional to the mass. So the acceleration is equal to whatever that force is divided by the mass. Well, when we're talking about electrons and protons, the masses are fairly small. And so when they experience a force, they accelerate fairly rapidly. And so what happens here is when these electrons, let's say, come off this negatively charged plate and accelerate towards this positively charged plate, they're speeding up the whole way over. So they're getting faster and faster and faster and faster as they move between these two charged plates. Okay? And one way to make the particles go even faster is to do this in stages. So for example, let's say this is a positively charged particle, a proton, and the proton comes out of here. Well, what's going to happen to a positively charged particle? It's going to be attracted to this negatively charged tube over here. And so that it will experience an attractive force, and so it will accelerate as it goes through. But then right when it gets here, ordinarily what would happen is this positively charged particle would say, well, wait a second, I want to stop moving to the right. I want to start moving to the left. I want to go back to this negatively charged plate. And over here I have this positively charged plate. I actually want to get away from this positively charged plate. I'm a positively charged particle, and like charges repel. So ordinarily what would happen is this positively charged particle would accelerate, get faster, 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 faster. And right when it got back here, it would want to slow down. But what they do is they change the charge on these tubes very, very quickly. So now they make this tube negatively charged. So right when that positively charged particle gets right about in the middle of this negatively charged plate, they change the charge on the plates. And so they make this now negatively charged. So what happens to this positively charged item is it now wants to continue speeding up to the right because the positively charged particle is now attracted to the negatively charged tube. So it accelerates even more. Right when it gets about here, they change the polarity again. So now this will no longer be a positively charged, this will be a negative charge. Now this very rapidly moving positively charged particle will now pretend it's up here now. It's going to now be attracted to this negatively charged. Right about the time it gets out, they again flip the charge again. And so now this positively charged proton again gets accelerated to the right. And so by very, very quickly, I have to do this very quickly, but we can very quickly change the charge on these tubes here. And so we can effectively keep making this proton go faster and faster and faster. So it will be accelerating towards this negative tube, and then pretend we're down here now. It will continue accelerating towards this negative tube, and then up here it'll accelerate towards this negative tube, and then it'll accelerate towards this negative tube. So we very quickly change the charge on these tubes, and we can get a proton to accelerate and get faster and faster and faster. Okay? Let me just give you a little demonstration of that. So these tubes, it all comes down to timing. You have to quickly change these tubes from positive to negative so that the charged particles continue to get accelerated to the right. So it comes down to timing. You have to very quickly change the charge on these tubes. But it all comes down to just opposite charges attract and like charges repel. All right. So in summary, the way we accelerate particles is we just tap into that basic thing that we already know, which is that positive particles will have an attractive force to negative particles, and negative particles have an attractive force to positive particles, and like charges repel. And we also know that whenever there's a force on an item, it's going to result in an acceleration. So by using these oppositely charged particles and like charged particles, we can get a charge to accelerate down this tube. So when these particles experience a net force, they accelerate. Charged particles experience these forces due to the electrical attraction and repulsion, and that causes the particles to accelerate. And if we want to get really fast particles, we can use multiple stages to increase the acceleration and make the particles go even faster. All right, so that's just the basic idea there. Now I'm going to also attach a YouTube video that just talks about some of the uses of particle accelerators. We use them for experiments in physics, but they're also used in many practical applications such as healthcare. And you'll see that in the video. Alrighty, so watch the second video and then answer the questions in the attached form. Okay, thank you.